We're here at gotomath.com, and we're going to be looking at some optimization problems. Optimization. Alright, what do we got going on here? We're doing number 1 here. Let's just click on it. 1-1. Get that to come up. Find two positive integers that has a product of 196 and their sum is a minimum. Whoa. Alright, it's not too bad. Okay, so we start with easy stuff first. So let's write that down. Okay, let's go over to the whiteboard and let's see what we got. So we need to find two positive integers. We'll call the two integers x and y. All right. And it says that their product is 196 and their sum is a minimum. So I'm going to say minimum. I'll just say min here. Their sum, we'll call S the sum, is equal to x plus y. Their sum will be a minimum. Okay. Alright, so this is the primary equation here. They call this the primary equation, and they call this is a constraint, but they call it the secondary equation. And equation, I guess we'll say. The primary equation, the secondary equation. Okay, so the way this works is all you have to do, we want to get this equation here in terms of just one of the variables, either x or y. Okay, in terms of x or y. So what we'll do is we'll take this equation here and solve. We'll solve for y up here in this equation. Okay, so I'm going to take this equation, we'll rewrite it right down here, and I'm going to solve for y. So y is equal to 196 over x, right? I just took x, brought it down here. Okay, then what we'll do, this is called direct substitution, and then what we'll do, we'll take it and plug it in for y right here. So we end up with s is equal to x plus 196 over x. Okay, so we got everything in terms of x over here. All right, now what we'll want to do is what we're going to want to do here is, of course, take the first derivative, set it equal to 0, and solve for x. Because this right here, if you look at the graph, you'll want to look at the graph. Now, we graphed a function that was similar to something like this. I'm trying to remember what that graph looks like. We graphed a function that was similar to this. I can't think what the graph looks like. Anyway, it doesn't matter. What we're going to do is we're going to see where this is a minimum problem, right? Min. We want to find the min. All right. So what we're going to do now is take the derivative, right? But first I'm going to rewrite it, okay? So we can take the derivative. It's a whole lot better to do it this way. Bring that x up into the numerator here, okay? We can do that because it's just a constant up here. Now we'll take the derivative. We say s prime is equal to, so the derivative of x is 1, and then bring that negative out front, x to the negative 2. And then what we'll do now is set this equal to 0, and I'll actually rewrite this. Okay, and let's why don't we, so I don't have to keep scrolling down the screen, we'll continue this right here. Alright, so I'm going to take this 196x squared over to this side, so we have 196x squared squared is equal to 1. And x squared, bring this x squared up here. And then we will square root both sides. Plus or minus 196 equals x. Okay. Now remember, we were looking for two positive numbers, and so we won't be using the negative here. Okay, we won't be using the negative. The negative. All right. Now, what you could do to test that this actually is a minimum, right? You could take 196 and actually, you know what? The square root of 196 is 14. Let's simplify that down. Now, of course, we're just using the positive, right? The positive one. So what you could do, since this is considered to be a critical number, right? You could take 14 and test if this actually is a minimum. So we should have decreasing and decreasing over here on this side here. So you could take, for example, 13 and then take 15. Right, so we're just testing to see if this is a min or a max, but it's a minimum, but we're going to test anyway. So take the 13 and plug it into this first derivative, which we'll look at this one here. So if you had 13 squared, you'd get 169, right? And so 169 into 196 is going to be a number a little bigger than 1, right? A little bigger than 1. 196 over 169. Be a number a little bigger than 1, so 1 minus a number a little bigger than 1 is going to be a minus, right? And it would be a negative number. And so you know that this is decreasing. And of course, if you take 15 and then you square that, obviously that's going to be a number bigger than 196, right? 15 squared, because we know 14 squared is 196, so this is 255. So this ends up being 255 down here when you plug 15 in. And so now it's a number that's actually less than 1. 1 minus a number less than 1 is going to be a positive number. So you know it's increasing, right? So we know that there's a minimum taking place right here. Okay, so we do that just to kind of show you that this is actually a minimum. All right, now what we're going to do is we need to we've got one of the numbers. Now what we need to do is find y, the second number, right? So let's go back up to here, okay? And we can find now what y is, right? We can find what y is, okay? So we know that y is actually, I'll just write it right here. How's that? Y is equal to 196 over x, and y is equal to, we'll go ahead and plug it in now, and x is 14, right? So since 196 is 14 squared, then we should have 14. So it turns out that y is equal to 14. So our two numbers, x is equal to 14 and y is equal to 14. Okay, so we come back up here. Now we look at this. If you took 14 times 14, you get 196. And then, of course, 14 plus 14 is actually that actual sum is going to be 28. Okay, 28, right? So there's a whole bunch of numbers we can multiply together to give us 196. But when we add those numbers, right, we want to make sure that the two numbers that we add together is going to give us the smallest sum. So that's pretty cool, I think. Okay. So let's go in here. Let's make sure that everything's good on that. And it looks like. So we set it up as our primary equation. Our sum is equal to x plus y. And then we call this our secondary equation, which is our constraints. And we have x times y is equal to 196, therefore x and y. In this particular case are 14. Now, it said find two positive numbers, so there were two negative numbers, right, that we could have done that with. But we're using the two positive numbers. Alright, so you'll like this section. Come on back. This is the I really like this optimization problems is, man, utilized in the real world in a lot of different areas for a lot of different things. But anyway, so come on back. Let's apply this math. Hit this at gotomath.com and maybe I'll see you there.